In this video, we are going to learn about calculating masses in reactions using two examples. There is an important rule in chemistry, being that the mass of a reaction is always conserved. This means that the mass of the reactants must equal the mass of the products. Let's think about this. If you combust 12 tons of coal, which is mainly carbon, with 32 tons of oxygen in a power station, you should be able to calculate the number of tons of CO2 produced. Pause the video and think about this. Continue when ready. If you said 44 tons of CO2, you'd be correct because the mass has been conserved. In a different power station, methane, a hydrocarbon, with the chemical formula CH4, can be combusted with oxygen. Let's consider the question: how many grams of water vapour are produced when 1,000 grams of methane is combusted? The first step is to use a balanced chemical equation. What do you think the ratio is between the number of methane molecules combusted and the number of water molecules produced? Pause, think, and continue when ready. The answer is that 1 molecule of methane reacted with 2 molecules of oxygen for it to produce 1 molecule of carbon dioxide and 2 molecules of water. Did you get it right? The second step is for you to calculate the molar masses of methane and water. This is done by using the periodic table. Can you calculate the molar masses for methane, CH4, and water, H2O? Pause, write these down, and continue when ready. The correct answer is 16 grams for methane and 18 grams for water. It's useful when doing this type of problem for you to record the molar masses and their ratio underneath the equation as you go through the steps. The third step is for you to calculate the mass of the water produced by the reaction. 1 mole of methane produces 2 moles of water. If you know the molar mass of water is 18 grams, what do you think is the molar mass for 2 moles of water? Pause, think about this, and continue when ready. The correct answer is that the molar mass for 2 moles of water is 36 grams. The fourth step is for you to calculate the mass of water produced. In order to do this, you have to set up the equation as shown. Here's a challenge. How would you work out the mass of water using the above equation? Pause and continue when you are ready. The amount of water produced by combusting 1,000 grams of methane is 2,250 grams of water. This is because 36 divided by 16 gives 2.25. You then have to rearrange this formula for the unknown mass of water. This is done by multiplying 2.25 by 1,000 grams of methane combusted. So 2,250 grams of water were produced. Did you get it right? In summary, the steps are: 1. Have a balanced chemical equation. 2. Work out the ratio of reactants and products involved. 3. Calculate the molar masses of the reactants involved. 4. Set up the formula to calculate the unknown mass of reactants or product. And finally, 5. Rearrange the formula.